Welcome to this lecture, and with this lecture I am going to discuss threads and their management. My name is Saket Kumar Singh and I am working as an assistant professor in Department of Computer Science Engineering, AKGEC, Ghaziabad. So I hope you have already seen process synchronization, process scheduling. Okay, what does this process means? Okay, what is how we can define a process, okay, in operating system. So when we talk about this thread, so let's see what are these threads and how it is different from a process. So in this lecture the outline is, first we will see what is thread, how we can define a thread, what are the threads. Then we will see motivation behind using this thread architecture, or you can say multi-threaded architecture, or you can say multi-threaded models. Okay, then we will see benefits of using this thread. First, motivation is like why we have shifted, why we have moved to single process system to a multi-threaded system, and then we will see what are the benefits that we are getting when we are using this, benefits of using this threads. Okay, what are the benefits we will see in this lecture. And then different multi-threaded models we will see, what are the different models, multi-threaded models that are existing right now. And then we will see various thread libraries, what are these thread libraries and what help does a thread libraries provides to a thread to a programmer while implementing a thread. Then we will see some threading issues in brief. If I will get time to cover in this lecture, then I will go in deep, otherwise I will briefly introduce you what are the threading issues a programmers face while implementing a threads. Okay, so now what is thread? I hope many of you are aware of what is thread. A thread is a lightweight processes. Lightweight processes means, what is a process? A process, what is a process? A process is a program in execution. A process is a program in execution. So for example, suppose that if you have written a program, okay, I am just writing the basic, very basic, CLR, and suppose you just simply write printf. This is a simple program that you are trying to run in your system. So this program, when you will this is a simple hello world program, small program, and when you will try to execute this program, first you have to load this program into the main memory. So this is a very small program. You can count the lines by your own, like 1 2 3 4 5 6 line of codes has been used to print a hello world program in C language. This is a C language program. Okay, so when you will try to execute this, what is the flow? First this program must be loaded into the main memory and then it will be executed into the CPU. Okay, so when you are going to load this program, this is a very small program and will not cause any problem to you because this is very small. But when you are talking about a large program which are containing n number of functions, in which the programmer is invoking n number of functions, okay, so at that places, suppose to bring all the overall process into one main memory can be a problem. First thing. The another thing is, suppose that if you will break that program into n number and you can parallelly execute all those n number of breaks, the division, if you are executing all those parallelly in a multiprocessor system, that could be a benefit. So that is what is called a lightweight process, means you are dividing the program into n number of threads on n number of threads, means you are just breaking the program into threads so that it can be executed in a multiprocessor system parallelly, okay, or concurrently. So it is the basic unit of CPU utilization. Of course, when you are using a thread, it will increase the utilization of the CPU, it will increase the performance of the CPU. Okay, it comprises of a thread ID. Okay, so remember when you have studied process, the process concept, so there you might have studied this PCB, what is called as process control block. So what does this process control block holds? This process control block is a data structure which is used for containing some of the uh, information or attributes of the process, that process ID, or where in which state the process is residing now, and what is the next process that is to be executed, means the program counter, and all those details are stored in PCB. Similarly, when you are dealing with the thread, what are those things that are inside the thread? A thread ID must be there, and then program counter, of course, then a register set. A register set means it's equivalent register, CPU registers, and stacks. Okay, so this is a thread contains, you can say, and it shares its code section. It shares its code section, like if this is a program and you have broken this program into P1, P2, P3. Okay, you have broken this program into P1, P2, P3, and this is suppose your thread 1, this is suppose your thread 2, this is suppose your thread 3. Okay, so all these threads will share what? It's share their code section, then data section, because all these threads are from the same program. Okay, so of course obviously it will share the code section, the data section, and open files, signals, and other operating system resources with other threads as well. So all these threads are from the same program, so obviously these will share the code section, data section, and other operating system resources. So now we will see what are the motivation behind using this thread. So traditional process has a single thread of control. Traditional process has a single thread of control. Okay, so if a process has multiple thread, okay, then it can perform multiple tasks at a time. Okay, of course, if even if a process, you have broken the process into multiple thread, then it can perform the multiple task at the same time. We will see when we will see the example. An application is implemented as a separate process. So we are talking about an application here. So an application is implemented as a separate process with a several threads of control, For example, a web browser. Okay, let's see an example of a web browser, how a multi-threaded architecture is used in web browser. So a web browser contains only thread that display images or text. For example, one thread is ongoing for displaying you the images and text, and the other thread is responsible for retrieving data from the network. So this is the best example that we see in our daily life. We are accessing the web browser daily. So one thread display images or text, another thread can retrieve data from the network. So this is an example. This is an example. Now the next example is a word processor. What is a word processor? A word processor can be your Microsoft Word or Microsoft PowerPoint that we are using. So a word processor, you can see if a word processor is an application is a set of programs which are running right now. We are calling it as process, and these processes have n number of threads, in which one thread is responsible for displaying us the graphics. Okay, and another thread for responding to keystrokes by the user. So whatever the word or the paragraph that I am typing in my CPU system or the laptop, so the another one thread will be responsible for displaying the graphics, another thread for responding to keystrokes by the user, and third thread for grammar and spelling checking. Okay, so we can see we have taken the example of a word processor in which there are many threads which are running concurrently, but we have taken only 3 threads, okay, to show you the example that how multi-threaded system works. So this is a figure here. You can see aim is to use multi-threaded process instead of single thread. What are the benefits of using this multi-threaded? You can see a thread is having here you can see this is a single threaded means only one thread is there, and what are the things that are shared to this single thread? Code, register, data, files and stacks. But when we are talking about this multi-threaded architecture, you can see what this code is shared, data shared and file is shared to all the three threads. This is your thread 1, this is your thread 2, this is your thread 3. Okay, so among these all these three threads, what are shared? Code, data and files. Okay, each and every threads are having their own set of registers and stack, own set of registers and stack, own set of registers and stack. But what is shared among all these three threads? Code, data and file. So this is a an model, or you can say a multi-threaded process. This supports n number of threads. Okay, so this is your multi-threaded process. So now let's take one more example, which is your web server. A web server, how a web server can have n number of threads? Let's see. A busy web server may have to respond thousands of clients. A busy web server may have to respond thousands of clients concurrently accessing it. A busy web server may have to respond thousands of clients concurrently accessing it. Like suppose there is a web server which has now being like an AKtU, when result comes for semester, results come like 7th semester, 3rd semester, 8th semester result come. So what happens at that time? All the students are concurrently accessing the same web server for getting their result. Okay, so how this multi-threaded architecture can help? It has to service one client at a time if web server follows traditional single threaded process. Like if the web server is a traditional single threaded process, it has to handle one request at a time. And just imagine that how many number of students are requesting to that one particular web server for retrieving their results. Okay, so what is the solution to this? If we'll use multi-threaded web server, okay, one thread can listen the request while other can process the request. So this is the very best example. Like if even if you are booking a ticket at the time of Tatkal or something, or if you are if some result has been announced and you are going to check some results on the web server, and all the students are simultaneously requesting to get their result, at that time if you are using traditional single threaded if the process is traditional single threaded, then it will take a lot of time, or maybe the server will get crashed because it would not be able to handle the number of requests. But if you will use multi-threaded web server, one thread can listen to the request while other can process the request. So this is just an example, so I have taken only case of two threads. There are n number of threads, there are multiple number of threads that can run simultaneously. For if you want to see that, if you want to see the example, you can just click on Control plus Alt plus Delete and check on the task manager. Whenever you are whenever you open Google Chrome or something, you are running something Google Chrome, some new tabs, 1 tab, 2 tab. So according to you, only two process should be running inside the system. But when you will go and check inside the task manager, even two tabs can have n number of threads running inside your task manager. Okay, so these were the introduction to thread and benefits and motivation for use. Now let's see what are the benefits of using thread. First is it provides responsiveness. Program can continue even some part of it is blocked. Next point is, if one thread completed its execution, if one thread completes its execution, the output will be responded immediately without waiting for another thread to complete. Output will be responded immediately without waiting another thread to complete, like we have seen in the example, the web browser or the web server. Okay, for example, again a web browser can allow user interaction in one thread while an image is loading in another thread. Okay. So what other benefits? What are the other benefits? Like it provides faster context switch. How it provides faster context switch? Because the context size is less as compared to the context size of the process. Context size of a thread is very less. Okay. Context switching time for threads will be less as compared to context switching time for process. Why? Because the context size is less. In Solaris, context switching for threads is 5 times faster than the context switching for process. Solaris is an operating system. Okay. Next benefit is your effective use of multiprocessor or multi-core system. Of course, if you are broken the program into, if you have broken the program or process into n number of threads, though all those n number of threads can run take or can be loaded into different processors or different cores and can run simultaneously. If the process is divided into multiple threads and multiple threads can be scheduled to different processors or cores. Resource sharing. Resource sharing, in this resource sharing, it shares memory and resources of parent process by default. Resource sharing shares memory and resources of parent process by default, because even two or more threads are from the same program. So obviously it will share memory and resources of the parent process. Enhancing throughput of the system. Of course, it will enhance the throughput of the system. If we consider one thread as one job, the number of jobs completed per unit time would be more, and hence it will increase the throughput of the system. Other benefits are you can consider using this thread as economical, because how it is economical? Memory and resource allocation for process creation is costly. Okay, because process is larger in size as compared to thread. Okay, thread implementation does not require any cost. There are various APIs which we have already studied when we in lecture 5 when we are seeing your system calls. So thread implementation does not require any cost. There are various APIs. APIs means application programming interface for thread implementation. Okay. Different multi-threaded models are, threads are categorized into two types. First is your user level thread and second is your kernel level threads. Okay. So user threads are supported above the kernel. User threads are managed without kernel support. Kernel support means operating system support. Kernel threads are managed directly by the operating system. So different models, you can see various relationships between user level thread and kernel level threads are, first is your many to one model, then your one to one model, then your many to many model. Okay. So let's see about many to one model. Many user level threads are mapped to one kernel thread. For example, if I would like to draw a diagram, many user level threads are mapped to one kernel thread. Okay. So green thread in Solaris uses this model. Thread management is done by thread libraries. Thread libraries that we will see after this models. What are those thread libraries? So thread management is done by the thread libraries, and thread libraries are situated at user level, like Win32 or Java API or whatever. So all these thread libraries are reside in the user level space. This is more efficient, and it will, if one thread makes the, what is the disadvantage of this many to one is, like if any of this user level thread, user 1 2 3, any of this will make a blocking system call, it will block the whole kernel, and no other kernel system, though no other user level thread can run the system further. Only one thread can access the kernel at a time. So this is also a disadvantage. So multiple threads will not be able to run on multiprocessor system parallelly. Okay. So now the next model is one to one model. One to one model, each user level threads are mapped to a kernel threads. Okay. Other threads can run even if some thread makes a blocking system call. So the disadvantages of many to one has been removed there. Like, if you will draw a diagram, each user level thread are having their own kernel. Okay, so this is your one-to-one model. This also allows multiple threads. This also allows multiple threads to run on multiprocessor concurrently. Okay, because each are independent to each other, so we can run all those user level threads on a multiprocessor system, as all are having their own kernel. Creating a kernel thread whenever a user level thread is created could be a problem. So this is an overhead. So, okay, whenever a user level thread is called, it has to create a kernel always. Okay, so this can be a problem. Okay, we will see how this problem is handled by the thread pooling, which we will see in the threading issues. So performance of an application could be burdened by the overhead of creating kernel again and again. So performance could be hampered if we are trying to create the kernel again and again. So now the last model is many to many model. It multiplexes many user level threads to a similar or equal number of kernel threads. Like, if these n number of user level threads are there, all is multiplexed to different n number of kernel threads. There are this is not fixed, this is not bounded to any kernel thread. Okay, so users can create as many user threads as necessary, and the corresponding kernel threads can parallelly runs on multiprocessor system, of course. And a kernel can schedule another thread for execution. A kernel can schedule another thread for execution if some user thread performs blocking system call. Like, if this user has given a blocking system call, this will not affect any other user level threads, because there are n number of kernels. Okay, if each user level threads are bound to some kernel level threads, if each user level threads are bound to some kernel level threads, then it is called as two level model. It is a variation of many to many model. This is telling us that if, like, suppose this is un is mapped to kn. Okay, u1 is mapped to u1. So if we have fixed that this kernel will belongs to this user, that is your two level model. Okay, so these are some what is thread libraries. A thread library which provides us the API, or which provides the programmer the API for thread creation and management. Okay, so for implementing a thread, a programmer needs an API. So there are two approaches to implement a thread. First way is to provide a library entirely in a user space with no kernel support. Okay, and second is first way is to provide a library entirely in user space with no kernel support. Code and data structure for the library exist in the user space itself, and invoking a function, whenever a programmer will invoke a function in the library, results in local function call and not a system call. Okay, the another way is, second way is to implement kernel level library supported directly by OS. Okay, code and data structure for the library results in kernel space, and invoking a function in the library results in a system call. So I hope you have understood the difference in between the two. First, when programmer invokes a function, it will be a local function call, not a system call. But if you are using the second way of implementation, then invoking a function will lead to a system call, not the local function call. So different types of APIs are, first, I hope you have already seen this when we are discussing that API, POSIX pthreads. Pthreads, the thread and extension of the POSIX standard, may be provided as either as a user or kernel library. This is one of the thread. Another is Win32 thread, a kernel level library available on Windows system. And the last one is Java thread API, which allows threads to be created and managed directly by the Java program. Now the last topic is threading issues. So I am not going to discuss all the issues, but this is the very basic issues. So you can see whenever a programmer calls this fork function or execute function. So what does this fork function do? Fork function just create or duplicate the process. Okay, so you can see if one thread calls fork, does the new process duplicate all the thread or create a new process single thread? Okay, so this is a issue, this is a challenge, that if whenever we are calling a fork, whether it will duplicate all the threads or a single process with a single thread. Okay, so Unix support 2 versions of fork to support all both the two issues. Okay, same issue go with execute also. Now the next issue is cancellation. What is cancellation? Thread cancellation is the task of terminating the thread before its cancellation. Okay, means if the one thread, suppose if one thread will give the result, others will automatically gets cancelled. Okay, thread to be cancelled is called the target thread. Two types of cancellations are there. First is your asynchronous and another is your deferred cancellation. Deferred cancellation means like one thread has given us the result, then all the other thread which are, for example, that like you several threads are looking for a data in a database. Okay, so in that case, if one has got the result, all other will be terminated. Now these are some of the extra threading issues like signal handling, thread pools. What is a thread pools? It create a number of threads at process startup and place them into pool where they sit and wait for work. So this is when I was discussing many to one-to-one model, there creating all n number of threads was a challenge, was a problem. So these thread pools can help to resolve that problem. Thread specific data and scheduler activations. These are some of the issues. Thank you for this lecture.